Students, good morning. I am so happy to see you once again through CETEL YouTube channel. Today, we begin with one of the most important and fascinating subjects in chemical engineering. Most important and fascinating subject in chemical engineering, what we call the thermodynamics. Many of you may have often heard the term thermodynamics, but today you will understand how it forms the foundation to every chemical process. Foundation to every chemical process which you are going to study very shortly in your career. Clear? Good. Thermodynamics is a branch of science which deals energy and its transformation. Energy and its transformation. That means transformation of all kinds of energy from one form to another form. Transformation of all kinds of energy, from one form to another form. Clear? Thermodynamics is a branch of science which deals energy and its transformation. That means transformation of all kinds of energy from one form to another form. The name thermodynamics itself infers that thermo stands for heat, dynamics stands for power. I think now you are very clear. Thermodynamics is a branch of science was born to explain how heat is converted into power. Power is nothing but work done per unit time. Hence, we can say that thermodynamics provides quantitative as well as qualitative relationship between heat and work. Quantitative and qualitative relationship between heat and work. Another interesting information is thermodynamics is the only subject to provide the answers for the deepest questions in engineering. Say for example, I would like to point it out several questions. Deepest question in engineering. Question number one. How energy or heat is converted into useful work. Please understand the term useful. What I am trying to say is work can be completely converted into heat. First point, work can be completely converted into heat. Unfortunately, heat will not be completely converted into work. Work can be completely converted into heat. At the same time, heat will not be converted into work. The first question is how heat is converted into useful work. First question. Second question, many of the process occurs spontaneously or naturally. Many of the process occurs spontaneously, but some process needs external energy. Why? Third point, what are the limits set by nature for energy conversion. Clear? What are the limits set by the nature for energy conversion? These are all the simple or some deepest questions in engineering. Answer for this question provided only by means of thermodynamics. Clear? Coming to the point of chemical engineering. The application of thermodynamics in chemical engineering is abundant. The application of thermodynamics in chemical engineering is abundant. The knowledge of thermodynamics helps to analyze, optimize, design, operation and control of many chemical processes. The knowledge of thermodynamics in chemical engineering is helpful in analyzing, optimization, design, operation and control of many chemical processes, namely distillation, extraction, leaching, absorption, reaction, refrigeration, power generation and so on. In many process industries, namely refinery and petrochemical industries, polymer and biopolymer industries, refinery and petrochemical, polymer and biopolymer, food processing and preservation, many number of industries, textile, wastewater treatment and many other industries. So thermodynamic knowledge in chemical engineering is essential in analysis, optimize, design, operation and control of many chemical engineering processes, namely distillation, extraction, leaching, absorption, reaction, refrigeration, power generation. In many process industries, refinery and petrochemical industries, polymer and biopolymer industries, food preservation and processing industries, textile industries, leather, cement industries and many number of industries. I would like to point out several applications of thermodynamics in chemical engineering. First point, energy balance. First application. The knowledge on thermodynamics helpful in determining the amount of heat and work requirement. Heat and work requirement in order to operate the equipments such as fan, compressor, pumps, heat exchanger, and so on. These equipments are widely used in process industries. Thermodynamic knowledge is very much essential to calculate how much amount of heat and work required in order to operate the equipments, fan, pump, compressor, heat exchanger, and so on. Clear? First point. Second point, first one is energy balance, second one is phase equilibrium. Phase equilibrium in separation process. Thermodynamics helps to understand or helps to predict the conditions for vapor-liquid equilibrium, liquid-liquid equilibrium, and the solid-liquid equilibrium, which are essential for phase separation process. Say for example, distillation, absorption, adsorption, extraction, leaching. In order to get a successful separation, the knowledge on equilibrium conditions for equilibrium, vapor-liquid equilibrium, liquid-liquid equilibrium, solid-liquid equilibrium, these are much essential. This knowledge is provided by thermodynamics. Second case. Third case, chemical reaction equilibria. Thermodynamics helps to find whether the proposed reaction is feasible or not. Feasibility test. Feasibility of a reaction. Whether the proposed reaction will proceed or not. If you are able to find out the Gibbs free energy value, del G is equal to minus RT ln A. If del G value is less than 0, that means negative. Negative value means reaction is spontaneous. It will proceed on its own way. The rate of forward reaction is thermodynamically effective. When delta G value is less than 0, that means negative, the reaction becomes spontaneous. The reaction will proceed on its own way. Then the rate of forward reaction is thermodynamically effective. When it is equal to 0, delta G value, when it is equal to 0, the reaction is at equilibrium condition. That means the rate of forward reaction is exactly equal to rate of reverse reaction. There is no net change in reactants and products. Net change of reactants and products becomes 0 when delta G is equal to 0. Next, delta G value is greater than 0, that means positive. The reaction will not be spontaneous. That means the reaction will not proceed on its own way. It needs external energy for its completion. Clear? So once you are able to find the Gibbs free energy value, it is possible to find whether the proposed reaction is feasible or not. So feasibility test. This is the third application. Fourth application, refrigeration and power cycle. Refrigeration and power cycle. That means thermodynamic knowledge helps in analyzing and design. Gas refrigeration, steam power plant, thermal power plant, gas turbine, thermal power plant, thermal power plant, gas turbine. Analysis and design of gas refrigeration, steam power plant, thermal power plant, gas turbines by using thermodynamic cycles, namely Otto cycle, Rankine cycle, Carnot cycle, Brayton cycle. Clear? So if you are having enough thermodynamic knowledge, you can go for analysis and design of gas refrigeration, steam power plant, thermal power plant and gas turbines by using the successful thermodynamic cycles, namely Otto cycle, Rankine cycle, Carnot cycle and Brayton cycle. Another application, process optimization. That means the knowledge of thermodynamics is helpful in minimizing the energy requirement. That means minimizing heat requirement and maximizing the work production. Minimizing heat requirement. Maximizing work production. On yield by thermodynamic efficiency and irreversibility. Thermodynamic efficiency and irreversibility. Clear? This is the fifth application. Another one is environmental application. Environmental aspects or environmental application. Environmental applications. That means thermodynamics helps in combustion process. That means complete combustion or not. First point. Second point, amount of pollution formation and control. Third point, waste heat recovery. That means combustion reaction. In combustion reaction, complete combustion or not. First point. Second point. First point, complete combustion or not. Second point, pollution formation and control. Third point, waste heat recovery. This is most important. Waste heat recovery. So, applications of thermodynamics in chemical engineering is abundant. Clear? These are all the brief information regarding chemical engineering thermodynamics, which forms the foundation to every chemical process which you are going to study shortly in your career. Thank you.